Hello, I'm Mr. Craig and I wish to work out the odd problems for the worksheet where it's molar mass, where it goes moles to grams, and in some cases we'll go grams to moles. But let's start off with number 1 here, which deals with molar mass. So whenever you're working with this type of information, be sure to have your periodic table out. You always want to have your periodic table out because when we work with molar masses, the values that we have for the molar masses, I don't expect you to memorize. I don't expect you to memorize anything but the symbol on the periodic table. So let's take a look at number 1. So when it's asking for the molar mass, we're looking for if I had 1 mole or 6.02 times 10 to the 23 particles of sodium hydroxide, in this case molecules. So what we want to do is we want to use the molar masses that are on the periodic table. So whenever we look at these values here, the number below, that if I had 6.02 times 10 to 23 particles or atoms of sodium, it would weigh 22.99 grams. So that's what the molar masses are helping us to understand. So if I have a molecule or I have 1 molecule or I have a mole of molecules, and we'll be working with moles of molecules initially, I want to find out what is the mass if I had 6.02 times 10 to the 23 molecules of sodium hydroxide. So what we do is we look at the periodic table, we say, okay, well, sodium's 22.99, so we'll start off with that mass, and we only have 1 sodium in the equation, so there's no multiplier. We have 1 oxygen, and oxygen has a molar mass of 16 grams, and hydrogen has a molar mass of 1.008, and do use all the numbers that are on the periodic table. We won't round until the very end, and actually we will never round a molar mass because we'll typically be doing something with that. And then add that to the 1.008. And again, what these units technically are, it's grams per mole, but I generally don't show that until the very last step. And it's okay if you don't either, because normally we'll be using that mole unit in some other part of the equation. Not today, but later on we will. Actually, we will use it today. So calculating that out, I get 39.998 grams per mole. And again, when doing this one, simply just add all of these values together and that'll give me my value there. So let's look at the next one, number 3. Chromium chloride. So we have CrCl3. So go to the periodic table and find the molar mass for chromium, which is right here. How convenient, 52 grams. And we do only have 1 chromium, but we do have, in this case, 3 chlorines. So we have a multiplier, and again, go to your periodic table, find the molar mass for chlorine, which is 35.45 grams per mole. And then we simply just take 52, add it to 3 times 35.45, and if you're not sure how to type that in on your calculator, which is hopefully pretty straightforward since we don't divide anything, and that's how you type it in on your calculator. And that one is 158.35 grams per mole. Let's take a look at number 5. And here we do have silver, but we only have 1 silver. And silver's actually a little bit lower down, so let's scoot that over. It's in the D block here. Silver's right here, 107.87. So 107.87 grams per mole. We have 1 nitrogen, which is 14.01 grams. We have 3 oxygens, which is 16 grams. And some of you might be saying, well, where are you getting those numbers? So again, nitrogen's 14.01, oxygen 16. And when we put all of that together, we get 169.88 grams per mole. So hopefully that's not too difficult. Okay, so, and you will be doing molar masses almost every problem from this point on, unless it's kind of a neat little problem, which we'll talk about a little bit later on. All right, number 7. Here we have 3 carbons, so we have our multiplier, and carbon has a molar mass of 12.01 grams. And I have 8 hydrogens, which is 1.008. And again, those values, carbon 12.01, hydrogen, which we did in the first one, 1.008. And we type that all in, you get 44.094 grams per mole. Okay. So hopefully that's not too difficult, and most of you should be able to do that. So let's take a look at the next one. How many grams are in each of the following mole amounts? And again, use your periodic table to help you to determine, or to help you. So we always have to start off with what we know. So in this problem, we know we are given moles, and in this we're looking for grams. So we need to know how many grams. So kind of like what we did at the beginning of the year, where you did your dimensional analysis, factor labeling, the conversions. This is a conversion. We're going from moles to grams. And in that, be sure that you remember the sequence. And I discussed this in class, that generally speaking, you can start off with kilograms, milligrams, all those metric type units, but we need to eventually convert that into grams. Why do we need to convert it into grams? Because everything on the periodic table is in grams. So we want to go to grams, and then from there, we need to convert it into moles. Why? Because if I had 1 mole of sodium, it weighs 22.99 grams. So we always want to go to moles. And then later on, we'll work where we have molecules, and you can convert moles into molecules, which I don't believe we do today, but we will the next time we meet. And then we can take it one step further and find out how many atoms are actually in those molecules. What is really neat about this is a one-directional type problem. In other words, if I start off with grams, what I'm never going to do is I'm never going to go backward to kilograms to find moles. I will never do that. If you start going that direction, that's the only direction you're going to go in your conversions. If you're going in that direction, in other words, I start with grams and I'm looking for atoms, it's going to be a stepwise progression. I'm not going to move around and randomly go from place to place. So it is a one-directional situation here. And in this case, we know how many moles we have. So the question wants to know how many grams. So you're only going in that direction. And it's a one-stepper. Now, next time we meet, we'll have multiple steps. But today, we're just going to keep it simple. Okay? So again, start off with what you know. You know you have 1.60 moles of, looks like mercury 2 nitrate. And it wants to know how many grams. So in this case here, if it's not the unit you're looking for, move it diagonally. So my unit mole, I'm not looking for, so I need to cancel it out. So I'm going to put mole down here, and it's moles of mercury 2 nitrate. Okay. Now the really neat thing, whenever you're looking at a situation like this where you have moles within the problem, it will always be a 1. Why? Because whenever we look at the periodic table, it's always 1 mole of calcium weighs 40.08 grams. 1 mole of manganese weighs 54.94. It's always dealing with 1 mole. Now later on, when we do stoichiometry, that's a fun word. You're going to love that one. We'll have a balanced equation, and some of you might be tempted to use a different number, but always go with 1 mole. All right, so since we're looking for the grams, now it's just like what we did up here. So we just need to find the molar mass for it. And so the way to do that, go to your periodic table, find mercury. Mercury is not there. We need to move down a little bit. And scoot it over. So mercury is right here at 200.59. So the molar mass of mercury is 200.59 grams. And again, grams per mole. Notice that. So we have 1 mercury. How many nitrogens do we have? We actually have 2 nitrogens. Multiply that times that. And oxygen, I actually have 6 of those. Now, normally what I'll do is, just to help everybody out, I'll find out what the molar mass of that whole thing is. But again, when typing this in on your calculator, you don't have to find that out. But let me grab a calculator and let's see here. So the whole molar mass for this is 324.61. And then when you take 1.6 times 324, 519 grams. Now, that is my rounded answer because I have 3 sig figs. So again, start off with what we know. We know we have 315 moles, and this is, looks like nickel Roman numeral 2, because there's 2 nitrates, each nitrate's a -1 charge. But again, I'm not asking you to name it, but it's a good habit to get back into, because you will need to be able to name these things. So nickel Roman numeral 2 nitrate. So again, we're not looking for moles, so 1 mole of nickel 2 nitrate. And nickel 2 nitrate has a molar mass of has a molar mass of 182.95 grams. And how did I find that? I went to the periodic table and found nickel, which is 58.69, and add that to 2 nitrogens plus 3 oxygen. So here's how it looks. Actually, let me do that real quick. So 58.69 grams plus 2 nitrogen plus 6 oxygen. And all that weighs 189, or has a mass of 182.95. And when we type all that in, you get an answer of 576 grams. So 182.95 times 3.15 should equal 576. Looking at number 5, try this one on your own. Pause the video. Okay, you've had a chance to work this out. So again, start with what you know. You got 3.75 moles of your, in this case, iron Roman numeral 2 phosphate. And in this case, we have 3 irons. So iron is 55.85. And we have 2 phosphorus, which is 30.97, which is over here, 30.97. And there are 2 phosphorus. And we have 4 times 2, which is 8 oxygen. And the iron 2 phosphate has a molar mass of 357.49 grams. And again, that is per mole. So again, try to get rid of the unit mole. So 1 mole of iron 2, phosphate, not nitrate. And then when we type all that in, you get 1,300 and I'm going to say 40. I know my calculator's rounding here. That is grams. Okay. All right. Looking at the next one, how many moles are in each of the following gram amounts? So in this case, we're starting off with, get rid of that, actually. Just throw it out of the way. In this case, we're actually starting with a, let's go a different color. We are starting with a gram amount, and we're looking for mole. So in this case, it's moving only that direction. But again, it's only a 1-stepper. So make sure you can do it. So start off with what you know, factor labeling. we have 64.0 grams of water. And in this case, same thing, we're looking for moles, so moles will be on top, grams will be on the bottom, and we want to find out how many grams we have in 1 mole of water. This water. So to find the molar mass for that, you have 2 hydrogens, 0.008, plus you have 1 oxygen, and that whole thing weighs 18.016 grams per mole. And so when I take 64 divided by 18, my calculator gives me 3.55 moles of water. Okay, so when typing this in, make sure you're doing the correct order of operations. So again, 64 divided by, open your parentheses, 2 times 1.008 plus 16, close your parentheses. Notice I only have 1 set of parentheses, the beginning and the end, immediately after the division line. Don't go parenthesis 2, close parenthesis, times, open parenthesis, that, close the parenthesis. That changes the order of operation. So be sure you know how to use your calculator. Okay, so let's look at number 3. We have 195 grams of lead 2 nitrate. So again, because there's 2 of those and there's only 1 lead. So 195 grams of lead nitrate. So we want to get rid of the grams, so we'll find out how many grams we have, but we need, we'll always put 1 mole of lead nitrate. Again, that's because the molar masses on your periodic table are for 1 mole. So now we find the molar masses, and lead, needs to go down a little further. Lead is 207.2, so we have 207.2 grams. Plus we have 2 nitrogen, and we have 6 oxygen. And all of that together weighs 300, or has a mass of 331.22. Yeah, 22 grams. So when I calculate that, I get a little over half. I get 0.589 moles of lead 2 nitrate. Okay. Let's take a look at the last example, 500 grams of silver nitrate, or I'm sorry, silver carbonate. Okay, so again, start off with what you know. You have your 500 grams. Silver carbonate, and the reason why there's 2 is because silver has a +1 charge, carbonate's -2. Don't forget your charges. And again, 1 mole of silver carbonate. So we need to find the molar masses. So we have 2 silvers, which is 107, where'd you go? 107.87 grams. Plus we have 1 carbon, which is 12.01, plus 3 oxygen. And the molar mass for silver carbonate is 275.75 grams. And when I take 500 divided by 275.75, I get 1.81 moles of silver carbonate. All right, again, these problems are not as difficult or should not be difficult because the hardest component here is making sure that you're staying organized. When you're typing all this in, make sure that your order of operation is correct. So in this case here, which I didn't show, 500 divided by, open parentheses, and again, go slow, make sure you're understanding. Take everything that's in the red here. Okay, moving on down, right in there. Actually, let's put those back because your order of operation, we don't want to have parentheses in there. So it'll be 2 times 107.87 plus 12.1 plus 3 times 16, close the parentheses, and that should give you your answer that you're looking for here. Okay, so again, make sure you have the periodic table in front of you. And at this point here, I'm giving you the formula, so that shouldn't be too much of an issue to help you balance it.